This video is reviewing your chemistry reference tables to let you know what type of information you have available. So we have on the very front at the beginning, we have Avogadro's number. It tells you how many particles are in 1 mole of anything. The particles that we really focused on were atoms or molecules. So if you see atoms or molecules that you're going to have to calculate from grams or from moles, you're going to have to use Avogadro's number. The next thing we have is the gas constant R. There are 3 different values because it's been converted depending on your pressure units. So if you are has your pressure in atmospheres, you're going to need to use this value of R. If your pressure is in millimeters of mercury or torr, this is your value of R. And if you have kilopascals as your pressure units, then this is your value of R for the PV equals nRT ideal gas law equation. Standard temperature and pressure. Standard pressure is 1 atmosphere. And standard temperature is 273 Kelvin. We did both of those with gases, so they can mean those 2 points. Also, that is standard temperature and pressure, that is STP, and the volume of 1 mole of any gas at STP is 22.4 liters. And we use that in gas stoichiometry to go from liters to moles at STP. Also over here, you do have your pressure conversions. So if you have your pressure in atmospheres and need to convert to kilopascals, you can do that here or find those values here. All right, so then we get into thermodynamic constants. So we have heat of fusion of water, 334 joules per gram. This is used for melting or freezing. That's when you're going to use your heat of fusion. Heat of vaporization for water is 2,260 joules per gram degree C. And that's going to be used for vaporizing or boiling and condensation. So you're going to use these two when you are dealing with phase changes. And we'll look at the equations here in a minute. Specific heat of water is located here in all its various forms. Most of the time we used it as just liquid water. For our metals, important things that we have specific heat and we have the density of a lot of different metals. So if you need a specific heat of any of these metals, you can find it here. If you have a problem and can solve for specific heat, because you're given all the other information, then you can use it as identification purposes. Same thing for density, which is mass divided by volume. If you can figure out a substance's density, then you can identify the metal. Or if you need the density to figure out either the mass or the volume, you can find the density of these metals here. Okay, most of the time we don't really use that next page. So this page, the formulas page, is pretty important. You're going to have all of your formulas here. And then in this other column, they have any of the variables that need to be defined are defined. So if you forget what something means, you can look at it over in this area right here. So first we have density. Density is mass over volume. We use the triangle trick for that one. Always, when you draw your triangle, check and make sure that density is mass over volume. Otherwise, you have it written incorrectly. Kelvin conversion is next. Kelvin is equal to degrees C plus 273. We used Kelvin temperature exclusively when we were dealing with gases, and that's what the next few formulas have to deal with, are gases. So we have the combined gas law, P1V1 over T1 equals P2V2 over T2. You know you're going to have to use that gas law if you're given pressure, volume, and temperature, and they ask for another pressure, another volume, or another temperature. So it's about the same gas in just 2 different